So far, we've gotten an introduction to the Java programming language. One of the things like the various types of data, with the control flow, and we saw a bunch of the tools. In the second half of this discussion, we're going to be talking about object-oriented programming. Now, has everybody heard of object-oriented programming before? Brycean in C++, inheritance and methods and virtual functions and visibility and all that good stuff. It's all there in Java. It does a little bit differently than C++, and I think in some ways, at least circa 1993, C++ does it better. So the fundamental unit of programming in Java is the class, and classes contain methods that perform work. Now, most classes can be instantiated to create an object, and we say that an object is an instance of a class, right? We remember from our CS 101 course, a class is a description of some piece of data, and it has data and behavior on it. And what this means is that object-oriented programming separates the notion of what is to be done from how it is to be done. So if you think of what a class's methods provide, is really a contract that says, okay, well, here's what I'm going to do. So I've got a method with this name, and it takes these inputs, these parameters, and returns this output and maybe has these side effects. Oh yeah, by the way, if something goes wrong, I'm going to throw this exception. And really what that provides, from sort of an abstract view, is a contract between the code that calls the method and the method itself. So that's the what, is the contract. The how is the implementation of that contract. And that implementation can vary from object to object, right? You can have the same method provide that same contract in a different way. And this dynamicism is enabled by a feature of the language called dynamic dispatch, meaning that when you call a method on an object, the decision as to what code is actually invoked, which implementation of that method is actually invoked, is left until runtime instead of compile time. Right, and this is different from C, for instance, right? In a imperative language like C, you can start the main method, and as long as you're making plain old function calls, you know exactly what code is going to be invoked. And that's fine. That can be optimized 7 ways to Sunday, but it's not very flexible. In more dynamic languages like Java, the choice of what code to ultimately invoke is left until runtime. And this enables a lot of flexibility in the language. So I'm going to go quickly through this, and so stop me if it's something that's new to you. In addition to having methods which provide behavior in classes, there are also these things called fields, which is the data associated with a class. Now you can have something called an instance field, which means that the data is associated with a particular instance of that class, with an object, as opposed to class fields or static fields, which are associated with the class itself. These static fields, the value of that static field is shared by all instances of that class. Now, in Java, there are some naming conventions that I want to make you aware of. In Java, classes begin with a capital letter, something like employee. So I'm going to quick restart the timer. Capital E, employee. Whereas field and method names begin with a lowercase letter, something like just plain old lowercase name. And this convention is important because it helps you, as you're reading code, distinguish between, well, what's a class and what's a method. Fields and methods, called members collectively, are always available to their declaring class, meaning that you can, I have one method, I can call another method the same class, no problem. But you can control how other classes access the methods and the fields with something called access control modifiers. And these are probably familiar to you, right? You've got public, meaning that, okay, anywhere the class is accessible, that member is also accessible. You got private, which is on the opposite end of the spectrum, saying, hey, it's only available to the class in which it's declared. Protected, members are accessible from direct subclasses and by classes in the same package. So it's a little different from C++. You get this concept of a package. And then package level protection is actually the default, meaning that if you don't mark a method or a field as public, private, or protected, if you leave it blank, it means that it is available only to classes in the same package. Just the way it works.
You can't explicitly declare package.
You can't exist, and actually that's been a subject of some debate in the Java community. It's like, well, why can't you just, I mean, package is a keyword, just like public is. Why can't you have package there? And they just haven't, for whatever reason, changed it. Package level members are rare, I've found. I've used it, a handful of times. As a matter of fact, one of the times where it does become useful is when you're writing unit tests and you want to have a piece of functionality that's exposed just to your test but not to anybody else. And so if you have your unit test in the same package, it can work with package level members, where other classes can't. But other than that, I've probably only purposefully used package level members a handful of times in my career.
So protected as well does allow ones that are in the same package?
Yep. Okay. Yep. Who knew? And here again, probably not something you'd be taking advantage of, but it's the way the language works. Constructors. Constructors are, I call them pseudo methods. They execute code just like a method, but they can't be invoked directly. They're methods that initialize an object when it's created. And again, they're invoked kind of indirectly when you instantiate an object using the new operator. So like when you say, hey, new employee, that'll go off and invoke a constructor. The names of constructors are always the same as the name of the class whose instances they initialize. And while you can send parameters to a constructor, there's not really a return type. Just all the data comes in and is used to initialize the class. Methods perform some operation on behalf of the class and very often will work with the state of that object. So having fields that are public is not a good idea. Your objects should expose behavior, not state. Have a method that does the work. It might be the method is very simple. It's like, oh yeah, go take some value and store it in a field. But I think there are some advantages there. Can you think of why that would be a good idea? Why you don't want to have your fields exposed?
They can manipulate it not through your method.
Exactly. So if I've got a public field, it's public, other code can see it, and they can manipulate it directly. What if you want to later on add some logic to setting that value? So for instance, a permission check. Oh wait, you need to be running as a certain user. Or you want to say, okay, not only set that field, but maybe perform some other operation. There's no way to add that additional functionality to a field access because it's so direct. So instead, what you should have is like a setter method that will set the value, set the state in that object. And so when you work with methods, you invoke some method on what's called a receiver object and pass it some parameters. Here again, to that same point, here I have a little employee class that has some private fields, an ID, a name, and a boss. I have a constructor that initializes the employee with a given name, assigns it the next ID from this static next ID field, and I can set the employee's boss, like when there's a reorg, and I can also get the employee's boss. And by using methods to access the private fields, I protect them from other usages, other manipulation, and so then I can really clamp down and reason about how this object changes over time. So a method has a signature, which is basically the parameters, the number and type of parameters that the method has, and you can overload methods by having a method that has the same name but has a different signature. It takes different parameters. So here I can have a set name method that just sets the name, and here I have a set name method that takes two parameters and concatenates those strings together using the plus operator to get the full name. And we say that the set name method is overloaded. Yes?
What would be the purpose of overloading a method? You're writing the same code anyway.
That's a good question. I'll Anybody want to take a stab at it? Why? What's the big deal about overloading methods?
Overloading in this context with Java, where it allows you to have different parameter types, different types as parameters.
Yeah.
You can design like an API that's easier to understand for somebody else. Maybe it's simpler.
Yep.
Or wrapper functions.
Yep. Wrap. Yeah. So basically, but by overloading, actually, I'll give you a really. I think I've got a good example here from the Java API. Let me go off the Java docs real quick. No, it's Java 6 Java docs. Java 7. Okay, that's pretty. Let's go and find Java lang string. Oh no, actually, let's do string builder. Okay, so I think we'll dive into details about this. Ooh, it's really small. Next time. But string builder is a class that, well, appends various things to form a string. And it has an append method which is overloaded a lot, and it takes lots of different kinds of data. Now it's all the same operation. It appends some piece of data to my string builder, but it takes different types of data. And this is why you have method overloading. So you can say, well, append a boolean, append a double, append another string, append some various object, things like that. It's all the same operation, but it takes different parameters. Did that answer your question? Am I
Yes.
okay?
I guess what we're trying to say is using the same name, you can, because append is easier to understand, or maybe sum is another one.
Mm-hmm.
You can do different.
Right. I mean, you could instead have a method called append boolean or append char or append char string or append char string with offset and length. I mean, you sort of get it, right? I mean, and actually, maybe that's not so bad. But instead, the language allows you to overload methods, and the compiler is smart enough. Now, I don't believe that like old style C allows you to do this.
I found that was the biggest difference between C++, at least from the time when I learned, and the current Java, because C++ operator overloading was more in terms of arithmetic operators getting overloaded, where
Yeah.
you use the same operator like a plus with different data types, whether it was your built-in
Mm-hmm.
data types, or you had created a new data type like a vector class or something.
Yeah, I see operator overloading is a little different from method over. Well, maybe it's not. I suppose when you're like, hey, the plus, plus normally in this context would mean addition. Oh, but now it means go read from a file or something. Not a big fan of operator overloading. It's kind of dangerous. Anyway, yeah, good point.
One
Yeah.
of the programs that I wrote when we did in this department was operator overloading for a multi-dimensional array,
Mm.
where this is how I want this operator to work. If I say object A plus B, this is the operator overloading.
Yep. And Java doesn't have operator overloading. I think here's one. It was really out of style here again in like the mid '90s because C++ it was kind of awkward to do, and people really hadn't understood. There weren't enough people that really understood how to do it right in C++ for people for a critical mass to really say, oh, it's a good thing, it's the right thing to do. So there's a lot of backlash, and so yeah, Java said no operator overloading. Now, as it turns out, here we are 20 plus years later. There are some kinds of operator overloading that make sense, and I've seen some languages really use operator overloading in ways that are reasonable and valuable. Java doesn't have that, and probably never will, and that's okay. Because here again, different languages to solve different problems, different tools in your toolkit. Okay. Static members, static fields, and static methods are associated with an entire class itself instead of just an instance of a class, instead of just the object. If we go back to our employee example, here we have this next ID. It is static, meaning that all instances of employee share the same value of next ID. And so then when the constructor increments it, it'll increment it across all instances. They're basically like global variables, right? Everybody references the same value. Now, the fields, the instance fields are initialized in a constructor. Static fields are initialized in something called a static initialization block. And so you might see code like this. Here I've got some static field days of the week, and here I say static and then a code block, and I have code that initializes this static field. And when I want to reference a static field, I say something like the name of the class, day, dot, static field, static field name, like days of the week. And then it's an array, so I'm going to reference the second element, element 1. If you guys worked much with it, you guys really understand the difference between static and instance. I noticed in the past some students have struggled with it. Okay, if you don't have specific questions now, that's fine. I encourage you to go read up on it. Ask a question on the community, or come next week to come with it prepared. Similarly, static methods are invoked with respect to an entire class, not just an instance of the class. And because they are static, they don't have a this variable. Now, this is a special variable that can be used in an instance method to refer to, well, the object itself, the object on which that method is being invoked. You don't have the this variable inside a static method because there's no object there. There's only the class. And so when you invoke a class method, you say class name dot method name, give it some parameters. So if I had a static method like get day of 1, get day of I, when I say day dot get day of 1, that'll return Monday. And notice that in your hello world class, main is a static method, which means that that method was invoked without creating an instance of your hello class. Right? It's not like the VM does not instantiate hello before it calls main. It just invokes main. A new language feature that was introduced in Java 5 is something called static import. Now, we just saw that when you work with static fields and static methods, you have to say class name dot static field equals blah, or class name dot static method, go off and invoke it. And this kind of meant a couple of things. You had arithmetic functions that were kind of more verbose. So in C and Pascal, you would just say ABS, abs, for absolute value. In Java, you had to say math.abs. That was just more verbose, more stuff to have to type. You also had constants that had really long names like border layout.center. And things like that. So as a result, they introduced this language feature called the static import, which allows you to say, hey, I want to import all of the static fields, all the static members, all the static fields, all the static methods from java.lang.integer and java.lang.system. And so when you do this, it means that you can do things like, say, parseInt instead of integer.parseInt, because the integer class has a parseInt method. And you can say out instead of system.out. And you can say max value instead of integer.maxValue. And this saves you a lot of typing, no question. And when you're working in an IDE and you want to figure out what out means, you can just mouse over it and it'll tell you real easily. But on the other hand, I think there's a good argument to be said that this code is a little harder to understand. Because I don't know about you, but when I see parseInt, I expect this to be a method in the same class. I don't know where it is exactly. So I would say use static imports judiciously. So for me, I look at this, I don't think this is a very good example. However, there are lots of other times, and we might have time to see some tonight. Certainly, there's a couple of things in the screencast, definitely the JUnit screencast, where using static import can make your code a lot more readable because you're not having these big class names sprinkled all over the place. So it's a judgment call, and it's So I've seen places where static import's really nice. I've seen places where it's really not necessary. Okay. So think back to when you learned about C and C++, and a big part of working with the language was allocating and deallocating objects on the heap, right? You still are completely responsible for doing all of that, and that's hard, especially when you have long-lived objects. Like, how do you know when their lifetime ends? You need to collect them and everything like that. So. Java, because it has its own runtime in the Java virtual machine, um, manages manages cleaning up objects that are no longer in use for you. So you can allocate an object using the new operator. You can do this at any time. Maybe not. Okay. See, I can edit that out. But you but objects are implicitly deallocated by the garbage collector. So the garbage collector is basically this thing running in the background, looking at all the objects that you've allocated and looking for objects that are no longer in use, are no longer reachable by your program. So when an object is considered garbage, when all of the following are true. It's not referenced by a static field, so no static field is using it. It's not referenced by a variable in a currently executing method, so it's not being referenced on the execution stack. And it is no longer referenced by another non-garbage object. So basically what it does is it looks through memory, it goes and finds all of these starting points, if you will, in memory. Like, oh, static fields, okay. I'll start looking down the object chain of all the static fields. Oh, look here, all these methods that are currently being executed. They're using some objects on their runtime stacks, great. And then does this transitive closure, goes and walks the object graph and finds all of the objects that are still alive and says, okay, all these guys, save them, but blow away everything else. And that, at a very high level, in a nutshell, is how garbage collection works. This is very convenient because you don't need to worry about managing your objects anymore. So there is no delete keyword in Java. There is no free. And as a result, you don't have any dangling references. You're not going to have to worry about referencing memory that no longer is allocated. It actually makes the language a lot safer, right? You think about a lot of the exploits that native code is, security exploits that native code is vulnerable to. It's oftentimes due to poor memory management, right? Oh, look, I've deallocated something, and if I can get the pointer to the right place, though, I can now access data I shouldn't, or I can go execute code in places that I shouldn't. Java doesn't have that problem. However, you can still have memory leaks, right? A memory leak is just objects that's no longer used in the program, memory that's no longer used in the program, but is still allocated. And so if you're not careful about ensuring that objects that you're not going to use anymore are indeed become garbage, so if you accidentally hold on to big stuff into static fields and stuff like that, it won't get garbage collected. So it's not a silver bullet. You still need to think about some issues related to memory management. You just don't need to worry about explicitly deallocating things. Okay. Object-oriented programming makes code reuse much easier than in other programming languages. One way to reuse classes is to extend their functionality by subclassing them, right? And I assume you guys are pretty familiar with subclassing inheritance and all of that good stuff. So the whole idea is that when you subclass it, you take the functionality, the contract of that superclass, and you provide that contract. You might also add some more of your own contract, meaning that you can provide a new implementation for an inherited method, but you should not change the meaning, the semantics, that contract of that method. Because both the superclass and the subclass provide the same contract, have the same methods, you can use the subclass wherever you can use the superclass. This is a property called polymorphism that you can you've got you invoke some method on an object, and it doesn't matter what the whether it's a superclass or a subclass, where it is in the object hierarchy, as long as it provides that contract, it's going to do something. It'll work. Now in Java, excuse me, all of the classes, every Java class, including the ones that I write and the ones that you write, descend from a root class called Java Lang object. So in Java, everything is an object. And because of polymorphism, it means that we can take something like a string and assign it to a variable of type object. That's how it magically works. There's a keyword in Java called final, which a class that is marked as final is prevented from being subclassing. Similarly, a field that is marked as final cannot be cannot be modified, and a method that's marked as final cannot be overridden, meaning it can't have a subclass cannot declare that same method. And really, final is all about providing security in your code. In that, if I have a method, let's say it's validate password, and I don't want someone to be able to override it and change its definition to change its implementation to always return true. I can mark it as final, and any code that does attempt to override that method will not compile. The compiler will enforce the final. As a matter of fact, the compiler will enforce it, and then at runtime, when a class is loaded, when a class enters into the system, it is validated to make sure it's not doing anything nasty, anything it shouldn't be able to. And if you weren't able to generate, maybe some by hand or using a binary editor or whatever, a class file that overrode a final method, it would not be able to get loaded into the Java virtual machine. The Java virtual machine will do security checks on code that comes in. Fascinating stuff, I'm sure. Okay, final fields. Now, like I said, a field that is marked as final cannot be changed, meaning that it's only assigned to in constructors or when it's declared, which is essentially a constructor. So a field that is both final and static is basically like a global variable that cannot be changed, also known as a constant. And constants in Java are in all caps with underbars between words. So here's an example of a circle class that has a pi constant and some radius, and so the circumference is 2 times pi, here's a field reference, times this dot radius. The example here points out that pi is static, but radius is an instance variable. So I say this dot radius just to reinforce the point that radius is an instance variable. Okay, because every class, subclasses, inherits, or is descendant from Java-like object, it means that every class in Java has the following methods. So there's a method called equals, which compares whatever object is invoked on to some other object. Now this is value equality. This is not the same as pointer equality. You can say, hey, are they the same object with equals, equals, and not equals, those operators. But if I want to say logically, like let's say I have 2 strings. Right, 2 strings will be the same if they have all the same underlying characters. And so the string method overrides the equals method to do that comparison. Every object has an equals method, a hash code method, and we'll get into hash codes more next time. A method called clone, which returns a copy of the receiver object. A method called getClass, which returns an object which is an instance of the class that describes the class of the object on which it was invoked. Don't worry, we'll cover that later too. And also a method called finalize, which is invoked when the object is garbage collected. It's a little bit like a destructor, but no, not really. And we'll see some more details about that later. Okay, even more. Again, is this familiar to all of you? Anything new here? Are there any questions that maybe is like, oh, I didn't have a chance to, I didn't understand what that was all about in 202. Now that I see it, there's something I want to ask. Nope. Okay. How many more slides do we have? Okay, almost done. So I need a little break. Okay, abstract classes. Now, when classes are all about attempts to model realish world concepts, and sometimes you have sort of high-level concepts that you can't really make one of. So do I have a little animal hierarchy? No, I don't. So in the next couple of days, I'll be putting up a much more detailed discussion about object-oriented programming in Java. I go through this exercise where I have a class hierarchy that represents animals. So you've got down at the bottom, you've got cows and bees and turkeys and humans, whatever. But then as you go up, you have more abstract concepts like mammals and then insects. And then ultimately at the top you have an animal. Now, in the real world, you just don't have an insect. You have a particular kind of insect, like a bee or an ant. So insect, this abstract concept, is an abstract class in Java. Now, abstract classes allow you to represent these concepts that can't be instantiated and maybe don't have all of their behavior implemented. and so this is when you have certain behavior that's true for most instances, actually true for all instances, but then the actual implementation of that you want to delegate off to a subclass, you can have an abstract method or an abstract class. If you have, so basically what you end up with, and here again, you can watch the screencast for object-oriented programming to get more details on this, but you can have these like partial classes that maybe have some methods that are implemented and some methods that aren't implemented. You'll see the abstract keyword in a couple of places, and actually you'll see it in our assignments also. Okay, an interface is kind of like a class in that it specifies behavior, but it only has method declarations. It doesn't have implementations. And so it's basically sort of a marker to say, hey, here's a contract that you should provide, but I'm not going to tell you anything about how you provide the contract. I'm just going to tell you that what. I'm just going to tell you the method names and method signatures. A class can provide that contract by saying that it implements the interface. There's an implements keyword that you can use in your class declaration to specify that the class provides the methods on that interface. Interesting thing to note is that in Java, a class can implement multiple interfaces, but subclass can only extend one other class. So there isn't multiple inheritance of state in Java like there is in C++, which here again is sort of a product of the times. Back in the mid-90s, people were really anxious about multiple inheritance. They didn't like it. They didn't know how to use it. They could see how it'd be abused. And Java was like, well, we're not going to be like that. And so they didn't have multiple inheritance. Again, 20 years later, other languages are coming out that have multiple inheritance nicer than C++. So in and of itself, it's not a bad concept. It's just that at the time, there wasn't a good consensus on how to do it well. Blah, 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 blah. More details about interfaces. Now, I guess I'm a big fan of interfaces because they allow you to represent things in very abstract ways. And in our discussions of the standard Java libraries, a number of the APIs, especially the collections APIs, leverage interfaces extensively. And this is really cool because it allows your program to deal with things in the abstract, right? So like you just want some abstract type. You don't care what the actual concrete type is. And what this allows you to do is have flexibility in your program. So you can just change which particular implementation of the interface that you want to use in a given situation, and not have to worry about all of the code that uses that contract that then calls those methods. You don't have to worry about going back and changing all of those. It's one of the mantras in the class that I have is program to the interface. So when you're using someone else's code, use it in the abstract. Don't worry about using it in the concrete. So another language feature of Java is something called annotations. What annotations provide is metadata about a Java class. It allows you to, add some stuff. So they look a little bit like Java docs, but they're actually not just comments. They are a language feature. And so, for instance, you can mark things as @deprecated, or you can say that, hey, this method overrides another method. And you can, let's go to the example here. So you can say that, hey, I've got this class and it's deprecated. And deprecated means that it's like, well, I don't think it's very good anymore. It might be going away soon. Don't use this. I'll still support it for a little while, but it's going to go away eventually.
So how does the Java machine interpret that? It just doesn't compile it into a binary?
Well, it does actually. So that's a very good point. Annotations can be used at different points in your program lifecycle. So, for instance, annotations like @deprecated really only make sense at compile time. So, if you try to use a deprecated API, the compiler will issue a little warning saying, "Hey, you're using an old API. Are you sure you want to do this?" At runtime, the VM doesn't care whether or not you're calling a deprecated method or not. Other I guess I don't have. I guess all these examples here are compile time things. Suppress warnings tells the compiler, "Hey, don't complain. I know I'm using a deprecated API. Don't bother, telling me about it." Or override. It's like, "Hey, this method overrides another method. Please check that fact, Mr. Compiler."
So it's like a separate tool, for example, a compiler is processing the annotation.
For these particular annotations. There are other annotations though, and when you the annotation is like a type in the Java system. You can go, actually, let's go look at the API documentation. Annotations. There we go. So here is deprecated. Wow, look at all this stuff. Basically, what does it mean? The annotation, which for some reason they called at interface, it's so damn confusing. Anyway, this deprecated annotation, it's kept around at runtime, but I think it's only used really at compile time. And you can say, well, I can put this annotation on a constructor, on a field, a local variable, a method, a package. So annotations can only apply to certain program elements. Tonight, I just want to tell you that these annotations exist. In the JUnit discussion, and certainly when we talk about dependency injection with Google Juice, we'll use lots and lots of annotations. They're really powerful. They can do some really cool stuff. They're also kind of complex. They're complex to build. So looking at all of this stuff, yes, you should be a little confused and scared. But to use them, they're often really quite straightforward. So I think that's all the detail that I wanted to go into tonight. Just be aware there are these things like you can have an at whatever the hell before your method declaration. Okay, so once again, some differences between Java and C++ with regards to object-oriented programming. Again, Java doesn't have pointers, so you can't do pointer arithmetic. So you can't create an object and add 3 to it. Right? You can't do that like you can in C and C++. For those of you coming from a C++ background, the terminology is a little different. Instead of saying member functions, we say methods. Instead of member variables, we say fields. Instead of virtual functions, we say instance methods. Java does not have template classes. It has something called generics, which are a little bit like templates. Actually, well, they try to be a lot like templates, and they don't really get there all the way. Anyway, we'll talk more about that in a future lecture. Unlike C++, where you have to explicitly say which methods are virtual, by default in Java, instance methods are always virtual. There's no notion of allocating objects on the runtime stack. Are you guys familiar with this in C++? Stack, I call it stack variables. Is that what they're called? Basically, instead of allocating objects in the heap, they allocate the object in the stack if the scope of the object is just that method. It's a nice optimization, and interestingly enough, underneath the covers inside the VM, they'll perform that operation if the JVM figures out that, oh look, this object only lives for a little bit of time, they'll allocate it on the stack. But you as the program writer don't need to worry about that detail, which is actually kind of a nice thing. Java does not have multiple class inheritance. Again, you can implement multiple interfaces, but you can only inherit one class. You don't have friend classes in Java like you do in C++. You kind of have, you can have classes in the same package, which are kind of like friends. Maybe they're more like neighbors or something. But the whole idea of oh, you're my friend, and so here's access to all my private data, that's just a really weird thing. And they don't have it in Java. No explicit memory management. Again, the bang operator only works on booleans, so if you want to do a null check, you have to say not equals null. Unlike C++, or at least 90s era C++, there's not a separation between the declaration of the class and the definition of the class. No header files, everything's all the same thing. And all classes inherit from Java-like object. There's a common ancestor class. Okay, and so that's the review of Java. So in summary, Java programs are written with classes that contain methods, and execution starts with the main method. Java programs are compiled into this intermediate binary form called bytecode, which is then run on a Java virtual machine. And this is the mechanism by which Java programs are platform independent. Java, the language, looks a lot like C in terms of its primitive data types and control flow structures. And it has exceptions to encourage good error handling. Java classes, and there'll be a lot of Java classes in a Java application, are organized into packages. And there are a number of utilities that come standard with the Java development kit, such as the jar tool for bundling class files together into an archive, and the JavaDoc tool to create pretty HTML documentation from Java source code. Object orientation separates the data's interface, the what it does from the how it does it, its implementation. There are, inside a Java class, there are fields that hold data and methods that perform work. And you can have access modifiers on these fields and methods and classes too that encapsulate data and functionality and protect it from and prevent other classes from accessing it, from using it. Static members are associated with all instances of a class, and instance members are only associated with objects of particular instances of that class. And you can extend a class's functionality by using inheritance and overriding its methods. So that, in a nutshell, is the Java programming language, object-oriented programming. How was that? Was most of that familiar to you guys? Okay. Good. It was meant to be a review. I'm glad that you're familiar with it. And that really forms the basis of the sort of the day-to-day Java stuff that you'll be doing here in this course. Okay, I think it's time for another little break. Let's take another 10 minutes. It is 8 o'clock. We'll come back. We will go over the programming assignments, and then I think I want to do a little bit of live coding with you guys to show you sort of how you can start putting this stuff into action.